So we are going to look at radical reduction, and what that means is we are going to start with entire radicals, which is a radical where our coefficient is 1, and we're going to switch them into mixed radicals where they have a coefficient or a multiplier out in front. This is called, once again, radical reduction. So for the first one we're going to do, we're going to take the square root of 12. And you can do this a couple different ways, but what we're going to do is write the square root of 12 as a product of its prime factors. So that would be like using a factor tree and then saying that 12 is equal to 2 times 2 times 3. So that would be 12 wrote as a product of its prime factors. And because it's a square root, anytime we have a pair of factors, that means that we can simplify this, take this outside of from under our radical sign and write it as just 2, and then what's left inside after we've taken these out, because this is like saying the square root of 4, we have a 3 left inside, so it's going to be 2 times the square root of 3 is the only thing that's left. So we can actually kind of come up with a general rule for that. Another way of writing it is saying that the square root of 2 times 2 and then times the square root of 3 would be the same thing. So we're allowed to separate those. So in general, the square root of a times b is equal to the square root of a times the square root of b. So we kind of switch this to saying it's the square root of 4 times the square root of 3. So we'll do another one. The same idea. We're going to this time work with cube roots. So 432 looks like it's getting to be a bit large, but we chose this number on purpose. So if you were to write 432 as a product of its prime factors, it's going to be the cube root of, and it's going to be 2 times 2 times 2, which is the same as saying 8. So 432 divided by 8 gives us 54, and that's going to be times 3 times 3 times 3, and then finally times 2. So if you were to do a factor tree on this, this is what it would work out to be. And the reason we set it up like this is because now we've done a couple things. First of all, we've changed our index to 3. So now what we need is we can't just find a pair of factors, we actually have to find 3 factors that are the same. And we have that happening twice. So every time we have 3 of the same factors, because we're talking about cube root, we take and we write one of them outside. So in this case we're going to have 2, and then times, we're going to pull out our second factor here. So it's like we're saying, what is the cube root of 3 times 3 times 3? Well, the cube root of 3 times 3 times 3 is just 3. And you could evaluate that to find that out as well. And then what we have left under our radical sign is just this lone 2 here. So then what happens now, this is why we chose this question, is because I pulled 2 of them out, I actually multiply those together to get 6, and then we're leaving the cube root of 2 there as well. So if I check on a calculator, I can switch it to a decimal to confirm that I'm right. So the cube root of 432, if I was to switch it to a decimal, cube root of 432 is approximately 7.559, and then it goes on forever and ever. And if I was to check what is 6 times the cube root of 2, I get the exact same answer in a calculator. So that's a way to confirm that we're right. So now what we're going to do is look at the 4th root of 162, but this time we can use a slightly different method. So let's say for some reason that when you look at 162, you think about it as 81 times 2. And you know that 81 is a perfect fourth. Perhaps you have a list or you're just used to seeing it. And you know that, maybe off to the side, you know that 3 exponent 4 is 81. So what you could do is say, I know a perfect fourth that is a factor of 162 is 81. So you can just split it up right away. You don't have to prime factorize it. You could then say this is the same as the fourth root of 81 times the fourth root of 2. And then the fourth root of 81 is just 3. And then we have the fourth root of 2 left over. So it's the same as saying 3 times the fourth root of 2, or 3 fourth root 2. So that's radical reduction. You can also go in the reverse. So what's that going to look like? So because of our rule before, so we can write a new rule if we want. If we have a times the, and we'll call it the nth root of b, that's going to be equal to the nth root of a to the n times b. So that may look a little bit complicating right now, but we're going to do it over here using actual numbers. So what I would want to do is take 3 and write it as the square root of a number. So 3 is equal to the square root of 9. And why do I know that? Well, I know that 3 squared is 9. So if this is true, this must also be true. So what I can do is I can rewrite this, and I can say, I think of it as taking the 3 and putting it back in under the radical sign. But in order for me to put it in there, if this index is 2, I have to raise it to the exponent of 2 to put it in here. So I can write this as the square root of 2, that 2 is represented here, times 9. I took the 3, put it back in under the radical sign, but I've got to square it in order to do that. So this is going to be equal to the square root of 18. So that's going in reverse, going from a mixed radical to an entire radical. We'll do it again. This time we're working with cube root. So what I'm going to do is I'm going to rewrite it as the cube root of 5, which is the same, but now I want to put the 2 in here, so I have to raise it to whatever this exponent is. And I have to multiply. So I could write it like that. And then simplify this part. So that's the cube root of 5 times 2 exponent 3 is 8, and 5 times 8 is 40. If you check it on a calculator, what we started with and what we ended up with should be equal. One more. Zoom in a little bit less. So I'm going to write the 7th root of 10, but now I want to put that 2 back inside, so I'm going to raise it to this exponent. I'm going to need a calculator to do this one. So 2 exponent 7 is 128. And then that means we can just multiply by 10. So it's going to be the 7th root of 1280. And that's going from a mixed radical to an entire radical.